In this video, we're going to talk about supplemental examples from 8.4, trigonometric substitution. Let's go ahead and use the trig sub x equals a secant theta to find the integral of x cubed over the square root of x squared minus 9 dx. So if x is equal to a squared is 9, so a is 3, so x is going to be 3 secant theta, making dx equal to 3 secant theta tangent theta d theta. So 3 secant of theta cubed times a 3 secant theta tangent of theta d theta, or square root of 3 secant theta quantity squared is 9 secant squared theta minus 9 is going to be 3 cubed is 27 secant cubed theta times 3 secant theta tan theta d theta over square root of 9. That's going to factor out as a 3 square root of secant squared theta minus 1. Secant squared theta minus 1 is tangent squared. That 3 and that 3 will cancel. 27 secant cubed theta times secant theta tan theta d theta over square root of tangent squared theta is a tangent theta that will cancel out with that tangent theta. And that leaves me with 27 integral secant the fourth theta d theta, which is 8.3 case 2a from our notes, where we're going to save a secant squared theta d theta. 27 integral save a secant squared theta d theta. Have a secant squared theta that's going to turn into a 1 plus tangent squared theta, secant squared theta d theta. And that is 27 integral of secant squared theta plus 27 integral of tangent squared theta secant squared theta d theta. It's 27 tan theta plus 27 tangent cubed theta. 27 divided by 3 is 9 tangent cubed theta plus c. But I'm not done yet, because now I need to get to the point where I actually do the substitution with my triangle. If I go back to the fact that I said x is equal to a secant theta, 3 secant theta here, that means secant theta was equal to x over 3, and this side here was x squared minus 9. Was where that square root came from. There's my theta. And so I have 27 tangent is going to be square root x squared minus 9 over 3 plus 9 times tangent to the third, x squared minus 9 over 3 plus c, like that. So this is going to be 9 times x squared minus 9 to the 1/2. And then this is going to be 9 over 27 is going to be 1/3. X squared minus 9 to the 3/2 plus c. And that'll do it. Don't forget to get back to x's. Don't just answer in terms of theta and be done. All right, this one is like 8.4, number 33 from the textbook. Integral of x, square root of 4x minus x squared dx. Let's go ahead and complete the square before we decide what form this is in. X dx, square root of, and then we're going to have a negative x squared minus 4x. And then the magic number here is going to be half of this number squared is plus 4. We added a negative 4, so we're going to add 4 here. So that makes this into square root of 4 minus x minus 2 quantity squared, like that, which is a squared minus u squared. So that is not this one. This is where we're going to get u is equal to a sine of just do it this way. Sine of theta, so a u is equal to a sine of theta. That's the way that I want to say that. That's the substitution that I'm making here with this, where u is equal to x minus 2. Du is going to be dx. So u is equal to 2 sine of theta. Du is 2 cosine of theta d theta. And x is equal to u plus 2 here. X is equal to u plus 2. Dx is equal to du. And then this is a squared minus u squared, like that. So let's see if I can make my substitutions here. 4 minus 4 sine squared theta for my u squared. And then I have 2 sine of theta plus 2 times 2 cosine of theta d theta here to change everything into thetas. And that gives me 2 factors out. As 2 times 2 is 4. Sine of theta plus 1 cosine of theta d theta. Square root of 4 is 2. Root 1 minus sine squared theta. Underneath that is a cosine squared theta that cancels out with this cosine theta d theta. And I have 2 goes into 4 2 times, leaving me with a 2. Integral of sine theta plus 1 d theta is 2 times negative cosine of theta plus 2 theta plus c. Now I need to draw my triangle here to say that sine theta was u over a. So that was u minus 2 over 2. So x minus 2 over 2 for sine theta, x minus 2 over 2, making this side here 4 minus x minus 2 squared, or 4, what did I end up with that in there? 4x minus x squared. Was that original square root that I started off with there? All right. So let's make some substitutions now. -2 cosine of x is root 4x minus x squared over 2 plus 2 and theta if sine theta is equal to x minus 2 over 2. Theta is equal to arc sine x minus 2 over 2. Plus c. So this is going to be a negative square root of 4x minus x squared plus 2 arc sine of x minus 2 over 2 plus c, or I can flip that around if I want to. 2 arc sine of x minus 2 over 2, write the subtraction second, 4x minus x squared plus c. All right. Now for this next one, I have 4 over 4 plus x squared squared, so I have an a squared plus u squared situation. I think I want to make u equal to, or x equal to a tan of theta here. So x is going to be equal to 2 tan theta, and dx is going to be a 2 secant squared theta d theta. And we have 4 and then dx times 2 secant squared theta d theta over 4 plus and then 2 tan theta squared is 4 tan squared theta, and this is all quantity squared. So this is 8 secant squared theta d theta, and this is 4 squared is 16, 1 plus tangent squared squared. So this is 8 over 16, that reduces to 1/2. Secant squared theta d theta. 1 plus tangent squared is secant squared. Squared is going to be secant squared theta d theta over 2 secant to the 4th theta is going to be 2 secant squared theta. D theta is left up there. So I'm going to pull the 1/2 out, bring the secant squared up as a cosine squared theta, d theta. And then I'm going to use my power reducing formula that we've talked about. And this is going to be 1 plus cosine of 2 theta over 2. D theta is 1/4 of d theta plus 1/4 of cosine of 2 theta d theta. So that's going to be 1/4 of theta plus, and I need a 2 and a 1/2 here. So that's 1/8 of sine 2 theta plus c. And then we'll simplify that down here. So we have 1/4 theta plus 1/8 of sine 2 theta is 2 times sine theta times cosine theta plus c. And I'm going to use my substitution here. The x was equal to a tan theta, so x over a over 2 is equal to tan theta. There's theta, there's x over 2. And that makes this square root of x squared plus 4, or 4 plus x squared, whichever order that was in. And so we have 1/4 arc tangent of x over 2 plus 1/4 times sine x over square root of x squared plus 4 times cosine 2 over root x squared plus 4 plus c. Well, that 2 is going to go into there and make a half. So this is 1/4 arctangent x over 2 plus x over 2 times x squared plus 4. And I'm going to pull a 1/4 out of everything here and make this arctangent of x over 2 plus 2x over x squared plus 4 plus c. I'm going to leave it like that for my final answer. All right, this last one is, I think this is the last one, is going to be using the substitution that a u is equal to 3x here, and du is equal to 3 dx. And when I do that, I'm going to get x is equal to u over 3. So u over 3 square root of 9 times u squared over 9 plus 1. And dx up here is going to be du over 3. So I'm going to multiply here by 3 over 3 to get rid of these divided by 3's. And that changes us into du over u square root of u squared plus 1. And when I see u squared plus a squared, I want to use the tangent one there, where u is equal to a tan of theta. So u is equal to 1 tan of theta. Du is equal to secant squared theta d theta. And so this is secant squared theta d theta. U is tan of theta, square root here of tangent squared theta plus 1. And tangent squared theta plus 1 is secant squared. So this is secant squared theta d theta over a tan theta. And the square root of a secant squared theta is a secant theta. That makes just a single secant theta up here. So secant theta d theta over tan of theta. I'm not recognizing that off the top of my head. So I'm going to change this into sines and cosines. Divided by sine over cosine. It's going to be 1 over cosine times cosine over sine. Cosines, and I'm left with an integral of a cosecant theta d theta is a negative ln of a cosecant theta plus cotangent theta plus c. There's another way that I could do that as an ln of cosecant theta minus cotangent theta plus c. I get the same answer here, but I'll do this one that I've memorized. And I'm going to draw my triangle here that I had u was a 3x, and I have tangent is u over 1, so 3x over 1, and this was root 9x squared plus 1. That's where that came from. And now I have negative ln of cosecant is the reciprocal of sine, so that is 9x squared plus 1 over 3x plus cotangent is cosine over sine. Adjacent over opposite, like that. And so that is a negative ln of, and then this is 3x, and then root 9x squared plus 1 plus c, and that's it. So there, the same thing. I could also have written my answer as this if I had used the substitution of ln of cosecant theta minus cotangent of theta plus c. It would have led to an answer that looked like that, but this and this are exactly the same. So there you go. They only vary by a constant, if anything. All right. So again, that's it for this set of problems. We'll come back next time and talk about supplemental examples from 8.5. See you for the next video.